Hello friends, today we will be studying histology of cartilage. Now, cartilage is a specialized connective tissue. It consists of two basic components, cells which make up 5% and extracellular matrix which constitutes 95%. Cells of the cartilage are called as chondrocytes. Perichondrium is a fibrocellular external covering of the cartilage and it has got two layers, outer fibrous layer and inner cellular layer. Now, internal remodeling. Matrix of the cartilage is dynamic. The old matrix is removed and new matrix is deposited by chondrocytes, and this process depends on stress and strain on the cartilage. And this is what is called as internal remodeling. The cartilage shows limited and slow growth. And how does that growth occur in the cartilage? Two types, interstitial growth and oppositional growth. Interstitial growth is wherein addition of new cartilage is done on the surface, and this increases the length of the cartilage, while oppositional growth is formation of new cartilage within the existing cartilage by division of chondrocytes. After maturation, cellular layer of perichondrium deposits new cartilage layers, and this increases the girth of the cartilage. Now, cartilage is avascular tissue that receives nutrition by diffusion from adjacent tissues. And based on the composition and mechanical properties of the matrix, there are three types of cartilages: hyaline cartilage, elastic cartilage, and fibrocartilage. Hyaline cartilage. This cartilage has a glass-like or transparent matrix, hyalos meaning glass. Hence it is called hyaline cartilage. It consists of chondrocytes, ground substance, and fibers. Matrix. It is basophilic and has a glassy appearance, shows spaces called lacunae which contain the chondrocytes. It consists of water, type 2 collagen fibers, proteoglycans, glycoproteins, and chondrocytes. The collagen fibers form a meshwork in the ground substance. They provide strength and stability to the cartilage. The refractive index of the collagen fibers and that of the ground substance is the same. Hence, these fibers are not visible in the histological section, thus giving the homogeneous glassy appearance to the cartilage. Chondrocytes here, these are the cartilage cells that lie in the lacunae in the matrix and are surrounded by an empty space within the lacunae. They divide and deposit matrix around them. The chondrocytes here lie in a group which is surrounded by territorial matrix, and these cells are rounded with flat opposing surfaces. Thus, they are D-shaped cells. These groups may have cells in twos and multiples of twos, and this group of cells is called as isogenic cell nests. The chondrocytes produce collagen fibers and ground substance. Chondroblasts, which are the precursor cells, get trapped in self-produced extracellular matrix, lose their capacity of cell division, and get converted into chondrocytes, which are the mature cartilage cells. Perichondrium here is the outer covering, or it is what covers the free external surface of the hyaline cartilage, and it has got two layers, an outer fibrous layer and an inner cellular layer. The outer fibrous layer consists of dense irregular fibrous connective tissue. The inner cellular layer has cells that divide and give rise to new chondrocytes. The outer layer has capillaries that provide nutrition to the cartilage through diffusion. Perichondrium is absent in articular cartilage, and it is absent at the site of direct contact between the cartilage and bone. This is how a slide of hyaline cartilage appears under low power field. So what we see here are the chondrocytes in the homogeneous matrix, and we also see the outer covering or the perichondrium. Another picture showing the perichondrium as the outer covering, the outer fibrous layer and the inner cellular layer. And here we see the groups of chondrocytes seen in multiples of twos or as two cells together. Chondrocytes lying in the lacunae, and these groups are what are called as the isogenic cell nests. And the matrix that we see here is clear, glassy appearance, hyalos-like, thus we call it as the hyaline cartilage. Another high power view showing us the perichondrium and the chondrocytes which lie in the lacunae and the clear glassy matrix. Another picture here. You can appreciate here the isogenic cell nests, the twos and multiples of twos. The functions of hyaline cartilage: maintains patency of the trachea and main bronchi due to the firmness, provides support and protection to the thoracic viscera due to its flexibility, and the articular cartilage provides smooth surface for movements. The sites where we see hyaline cartilage, we see it in the fetal skeleton, articular cartilages, nasal cartilages, costal cartilages, laryngeal cartilages, that is the thyroid, cricoid and the arytenoid cartilage except the tips of the arytenoid, the trachea and bronchi, and at the epiphysis of growing bone. Salient features for spotting: presence of homogeneous matrix, presence of chondrocytes forming cell nests, and presence of perichondrium. Now let us see elastic cartilage. Fresh specimen appears yellowish in color, hence it is also called yellow elastic cartilage. It contains ground substance, fibers and chondrocytes. It is surrounded by perichondrium. Ground substance is similar to that is seen in the hyaline cartilage. Fibers: they form a dense meshwork of branching and anastomosing fine elastic fibers. Few type 2 collagen fibers may also be seen. Chondrocytes here are bigger than those seen in hyaline cartilage and lie in the lacunae. They lie either singly or in groups of two. They produce elastic fibers, collagen fibers and the ground substance. Perichondrium covers the free external surface of the elastic cartilage. It has two layers, outer fibrous and inner cellular layer. The outer fibrous layer consists of dense, irregular fibrous connective tissue, while the inner cellular layer has cells that divide and give rise to new chondrocytes. The outer layer has capillaries that provide nutrition to the cartilage through diffusion. This is a low power field view of the elastic cartilage, where we can see presence of perichondrium, we can see large chondrocytes, and we can see a matrix which contains anastomosing elastic fibers. Another view showing us the elastic cartilage, where we see large singly placed chondrocytes which lie in the lacunae. And this is a high power field view where we see large chondrocytes placed singly lying in the lacunae, and around them we see branching and anastomosing elastic fibers. And this what we see here is the perichondrium having its two layers, outer fibrous and inner cellular layer. Another view showing us the chondrocytes, large chondrocytes singly placed in elastic cartilage. Functions of elastic cartilage: it provides elasticity, pliability, resilience and firmness to the structure. Sites where we see it in the body: ear pinna, external acoustic meatus, eustachian tube, laryngeal cartilages, that is the epiglottis, tips of arytenoid cartilages, corniculate and cuneiform cartilages. You can remember it as E for elastic cartilage, and sites are E for ear pinna, E for external acoustic meatus, and E for eustachian tube. Salient features for spotting: presence of matrix rich in elastic fibers, presence of large numerous chondrocytes in the matrix, and presence of perichondrium. We now see the fibrocartilage. Contains bundles of thick collagen fibers that give white color, hence it is also called white fibrocartilage. It is a combination of dense regular connective tissue and hyaline cartilage. It shows rows of chondrocytes embedded in the matrix and surrounded by bundles of thick collagen fibers. It does not have perichondrium. Fibers here are thick type 1 and type 2 collagen fibers forming the dense regular connective tissue. Some fibroblasts with flat elongated nuclei are present among the collagen fibers. Chondrocytes here, very few in number, lie singly or in isogenic groups within the lacunae in between the bundles of collagen fibers. Matrix. Chondrocytes lie within the lacunae of the matrix and produce matrix containing proteoglycans and glycoproteins. Functions of white fibrocartilage: helps in shock absorption, helps to withstand compression and shearing forces. Sites where we see fibrocartilage in the body: intervertebral disc, pubic symphysis, articular disc of sternoclavicular and temporomandibular joints, menisci of knee joint, glenoid and acetabular labrum. And this is how a slide of white fibrocartilage looks like. We can see thick bundles of collagen fibers, and in between we see very small chondrocytes present in rows which lie either singly or in twos, and in between the thick bundles of collagen fibers we see the flat nuclei of the fibroblast cells. Salient features for spotting here are: presence of matrix rich in collagen fibers, presence of very few chondrocytes arranged in rows, and absence of perichondrium. Now let us see the differences between the three types of cartilages. Matrix of hyaline cartilage is homogeneous glassy appearance. In elastic cartilage it is homogeneous, and in fibrocartilage it is dense homogeneous. Chondrocytes in hyaline cartilage are in isogenic cell nests in groups of twos or multiples of twos. In elastic cartilage there are numerous chondrocytes, large and singly placed. In fibrocartilage, very few chondrocytes, which are very small sized cells arranged in rows. Fibers in hyaline cartilage are type 2 collagen fibers. In elastic cartilage, these are branching and anastomosing elastic fibers. And in fibrocartilage, these are thick type 1 and type 2 collagen fibers. Perichondrium is present in hyaline cartilage and elastic cartilage, while it is absent in fibrocartilage. The function of hyaline cartilage is that it maintains patency, provides support, protection, and smooth surface for movements. Elastic cartilage provides elasticity, pliability, resilience, and firmness. Fibrocartilage acts as a shock absorber, withstands compression and shearing forces. Sites where we see hyaline cartilage is fetal skeleton, articular cartilages, nasal and costal cartilages, and epiphysis. Elastic cartilage is seen in the ear pinna, external acoustic meatus, and the eustachian tube, while fibrocartilage is seen in the intervertebral discs, pubic symphysis, articular disc, and menisci. And this is a picture showing you the chondrocytes of all the three types of cartilages. So we can see here in hyaline cartilage, the chondrocytes are present in groups of twos and multiples of twos, and they lie in the lacunae. These are the isogenic cell nests, and the matrix is basophilic, homogeneous, glassy appearance. While in elastic cartilage, the chondrocytes are placed singly they are much larger and numerous. Like in the lacunae, matrix has branching and anastomotic elastic fibers. Fibrocartilage, the chondrocytes are very small, very few arranged in rows, and they lie between thick bundles of collagen fibers. So that's how we differentiate between the three types of cartilage. The reference for this would be Sontakke Yogesh, Textbook of Human Histology, CBS Publishers and Distributors Private Limited, New Delhi, 2020, page numbers 69 to 76. Thus, we have studied the histological features of cartilage, and we saw all the three important slides out here. That is, slide of hyaline cartilage, elastic cartilage, and fibrocartilage. Thank you.